Hello and welcome to GeoProven, the Earth and Environmental Education Center of Provenance Geosciences in support of carbon-negative water and energy. I'm Dr. John Hoagland. In this presentation, I plan to review the angular relationships with parallel lines cut by a transect. And then that moves right away into a proof that the sum of interior angles of a triangle sum to 180 degrees. I think this theorem is quite beautiful, actually, very clever, and it really only involves just a tiny little bit of arithmetic at the very end. It's almost 100% visual, which makes it very approachable. This fundamental theorem in geometry, a great takeaway that the sum of interior angles of a triangle sum to 180 degrees. We use that theorem in very many applied problems. Starting at the beginning with a geometry class, we generally discuss a line. And actually what I have shown here is a segment, because a segment is a line that's terminated at both ends. So it's the line segment that runs between two endpoints. But we can assume that this line extends infinitely in each direction. Then we introduce the concept of a ray, where a ray starts at a point and runs in one of those directions infinitely. We indicate that with an arrow, in this case, to the direction of right. We next define an angle of 180 degrees, being the change in direction from going to the right to going the opposite direction to the left is a 180 degree angle. If we continue a 180 degree angle around again, we would return to the original direction and have turned a full circle. It's the Greek convention that a circle is 360 degrees, with that angle between the two opposite directions as 180 degrees. Next, we take another straight line and we cross the original line, intersect the original line, and that 180 degree sweep then is divided into two angles, one of which is acute, less than 90 degrees, the other one obtuse, and those two angles then, A and D, they must sum to 180 degrees. The angular measure there must sum to the 180 degrees to meet the original definition of 180 degrees. We can also identify a set of supplementary angles running along the other line, in this case the transect. Angles A and B are supplementary. So if A and B are supplementary and A and D are supplementary and they share A, angle D equals angle B, we define those angles as vertical. They're opposite sides of the intersection of the two lines. In a similar fashion, the opposite side of the two lines from angle A defines a vertical angle C, which is equal to A. At this point, we introduce the concept of a parallel line, in this case drawn below the original line. It too runs infinitely in both directions, and as a parallel line, by definition, it never intersects. Those two lines never intersect. As a result, it too is cut by the transect, and if that transect is a straight line, it defines the same set of angles. The angles E, F, G, and H then correspond to the angles A, B, C, and D. Students in a geometry class usually spend a couple of weeks getting to this point, especially if they're doing rigorous formal proofs. And then at that point they spend the next half of the semester or so looking at the angular relationships between these corresponding angles. First we define a region exterior to the two parallel lines, an exterior region below and an exterior region above. We also define an interior region between the two parallel lines. This helps us to identify the angles and establish relationships between them. At this point, there's a mixture of definitions and proofs that get to establish these relationships. First, some definitions. The following angles are considered corresponding angles. And we also prove that they're congruent. We can either do that by measurement or just by stating that the transect cuts the lines equally in the same angles, because the lines that are being cut are parallel. A and E are corresponding angles and are congruent. B and F are corresponding angles and are congruent. C and G are corresponding angles and are congruent. D and H are corresponding angles and are congruent. There's sort of a visual, intuitive nature of that, but this is something to establish. Next, we start working on the relationships of the angles in the interior region. And the first set that we have are consecutive interior angles. First one is B and E. Using B and E as an example, is if you walked along the transect line, you'd first encounter angle B, and then you'd encounter angle E, hence the name consecutive. The consecutive interior angles are supplementary. Another pair on the other side of the transect are C and H. They're also supplementary, meaning they add to 180 degrees. We also define angular relationships between the angles that are on opposite sides of the transect in the interior region, and we call those alternate interior angles, and they're congruent. The first example is B and H. Those angles are congruent. In fact, B and H are the obtuse angles. You can see that they're congruent. And the other alternate interior angles are C and E. Those are the acute angles. Next, we work out the relationship of the exterior angles. And we have a set that's similar. We have consecutive exterior angles that are supplementary. They include A and F. So if you were to eliminate the interior region and then walk along the transect, first you would encounter A and then you would encounter F. The other consecutive exterior angles that are supplementary are D and G. And there's a proof involved to get the proof that those are supplementary. Usually such proofs involve using the alternate interior angles are congruent theorem, and then using definitions of vertical angles and supplementary angles to establish the angular relationships. And all of that underscores how important the alternate interior angles are congruent theorem is. It's probably one of the most important takeaways from geometry, at least in terms of applied problems. If I had $1 for every time I've seen that in a proof somewhere in physics or in geology or you name the science, architecture, whatever, alternate interior angles being congruent is usually a large part of the setup. But ultimately, that's to prove that the consecutive exterior angles are supplementary. We also have alternate exterior angles, and those are the exterior angles that lie on opposite sides of the transects. They happen to be congruent. Again, that can involve a proof. It involves alternate interior angles getting there, and then vertical angles are congruent and definitions of supplementary. But at any rate, the alternate exterior angles that are congruent are A and G and D and F. They're on opposite sides of the transect. They're exterior angles, and they're alternate exterior angles, and they're congruent. It usually takes several weeks to get to this point in geometry where you make all of these proofs of the angle relationships. But if there were ever a screen or a page to memorize, this would be it. At this point, we can move into triangles. And what you might be asking yourself, what does this have to do with a triangle? All I see are angles. Well, we're going to build a special triangle. We're going to first concentrate on the supplementary angles in the interior region below the first parallel line, the upper parallel line. They're supplementary, and thus their sum adds to 180. Next, we draw our special triangle. It starts at the intersection of the transect with the first parallel line, and it cuts the angle B in two parts, arbitrary parts. We don't know what the value of those angles are, but we're going to call them X and Y. If we look at the supplementary relationship between C and B, we can replace the B in the sum, C plus B equals 180, with the sum X plus Y, so that we get a relationship. To complete the supplementary angle relationship, we have C plus X plus Y being 180 degrees. Next, we note that C and E are alternate interior angles, and thus C and E are congruent. So in the sum, we can also replace C with E, and we get the total E plus X plus Y equals 180 degrees. And here is the clever completion of our proof. It involves recognizing that the other side of the triangle that we just defined is also a transect cutting two parallel lines. And if you study that transect very carefully, you'll notice that the angle Y is an alternate interior angle with the remaining angle in the triangle. And given all of the previous relationships, E plus X plus Y equals 180 degrees. Thus the sum of the interior angles of the triangle is 180 degrees. All of these angles are completely arbitrary. They were never measured. We don't know their values. We could figure them out. But what we do know is that E plus X plus Y equals 180 degrees. And that is true for any triangle, simply because those angles are completely arbitrary, but the sum is the same. I hope you enjoyed that proof. At this point, the geometry course can move on. Typically, the next topic is quadrilaterals, which is four-sided figures, and that usually begins with parallelograms. Well, we can draw a parallelogram continuing with this diagram. And at least with parallelograms, you can see that there are a lot of angular relationships, both the corners of a parallelogram as well as bisectors cutting across the parallelogram, that can be solved using the angular relationship of two parallel lines cut by a transect. But I'm going to save that for another video if I get the time. And as the nature of modern geometry classes, which are combined with algebra, this figure was drawn in a graph software using equations for lines with various slopes. A lot of the exercises in the geometry class then become problems using the algebra, lines with slopes and lengths, to prove the geometric relationships. But again, those are topics for other videos. Well, I hope you enjoyed my presentation, and I hope that you at least take away two things: that alternate interior angles are congruent, and that the sum of interior angles of a triangle sum to 180. You'll use that in everything else, and I invite you to come and see examples of those applications at geoproven.com, the Earth and Environmental Education Center of Provenance Geosciences.